Alright, what's up guys? In this video, I'll pick up with some differential equations, and we're going to be talking about separable equations. So we're just asked to solve this separable ODE given that y of 0 is equal to ln of 2, so we're looking for the general solution basically. And so remember what we do for our separable ODE, we separate the variables, integrate both sides. All the y of 0 is equal to ln of 2 is, that's just us trying to find the value of the constant, that's it. And so we'll take it from there. So the first thing I'm going to do is actually rewrite this. I'm going to rewrite this as 1 over 3e to the x multiplied by dy over dx. And I'm going to write this side as e to the x multiplied by e to the negative y. Now we know if we have the same base in this particular case, technically we would add the powers, but there's a minus sign, so this is the same thing as that. I just broke it up, and it's good for us to break it up that way because remember we're trying to separate the variables. So let's multiply both sides by 3e to the x. If we do that, we get dy over dx is equal to e to the x multiplied by e to the negative y multiplied by 3e to the x. We'll multiply both sides by dx and then divide both sides by e to the negative y. So if we multiply both sides by dx, we'll get dy is equal to 3e to the 2x minus, or excuse me, not minus, but multiplied by e to the negative y dx. The next thing we do is divide both sides by e to the negative y. So this would be dy over e to the negative y. And that's going to be equal to what we have on this side, which is 3e to the 2x dx, which we can simply rewrite this as e to the positive y dy is equal to 3e to the 2x dx. Now we integrate both sides. So that's the goal, remember. You're trying to separate the variables so that you can integrate both sides. Okay, so we'll get e to the y, and that's just going to be equal to, remember that the, pull the 3 out, remember that the antiderivative of e to the 2x is 1/2 e to the 2x, so I'd multiply by 3, and that would give me 3 over 2 e to the 2x plus c. Now, the initial condition was y of 0 is equal to ln of 2. So we're trying to solve for the constant, basically, with the initial condition. Okay, so we just substitute it in, basically. So we'll get e to the ln of 2. It's going to be equal to 3 over 2 e raised to the 2 multiplied by 0 plus c. E to the ln of 2 is just 2. E to the 0 is 1. So we end up with 3 over 2 plus c. And if we subtract 3/2 from both sides, we'll simply get c is equal to 2 minus 3/2, which means that c is 1/2, or 1/2. So that's the value of the constant now. That's all the initial condition allows us to do. And we'll finish it up. Get another sheet. Alright, so this is what we got now. We got e to the y is equal to 3 over 2 e to the 2x plus 1/2. Hope you guys can still see. There you go. Now we need to solve for y, so we take the natural logarithm of both sides. So this would be ln of e to the y is equal to ln of all this stuff, which is 3 over 2 e to the 2x plus 1/2. So we can write our final answer down, our general solution. So the final answer here is going to be y is equal to ln of 3 over 2 e to the 2x plus 1/2. And that is your answer. Okay, pretty straightforward example. I got multiple examples of separable equations, so you don't always have to look at just this one example. So check out my other examples and let me know if you got questions. I'll see you next time.